Okay, so without more ado, I think we're ready to more or less burst into our lightnings, aren't we? This will mean, I don't know whether Mr. Minardi has yet got his talk. You were, oh, lovely. We've got
is here.
Another hardware-oriented talk coming up. But first, Katie Cunningham and Barbara Charette are going to talk about Young Coders tutorial earlier this week.
Woo, woo. Give him a hand.
Hello, everybody. My name is Katie Cunningham, and with Barbara Charette, we both taught a class of students from ages 8 to 18. We taught 2 classes, one class each day with 20 students on the first day and 15 on the second. We got them all the way up to object-oriented design, which is better than my college teachers could do with me. So let's talk about what tools we used.
We used idle to run them through all our code samples rather than using a regular Python interpreter. That was actually not something I was aware of when I wrote my slides. I thought we would just be using an interpreter, and it created some confusion as we got into entering multi-line samples. We used it because it was on the image, the Raspbian image for the Raspberry Pis that were donated for the class. The kids got to take the Raspberry Pis home with them at the end of the day, which is pretty nice for them. So they were able to follow up and continue working after they left. We did have to warn them about things like memory errors. One of the first things we taught them was how to multiply strings. And the kids were trying, multiply strings by 1 million and 2 million, the biggest numbers they could think of, and of course locking up their computers. The Raspberry Pis aren't really that powerful. But luckily the easy thing is to just unplug them and restart them, and they were off and going again. We also sent them home with 2 books, Python for Kids and Hello World, Computer Programming for Kids and Other Beginners. We didn't actually work directly from the books, but we sent them home to work after the class, so they have that follow-up, those projects they'll be able to continue working with after they've gone. I think that's it. Okay.
We designed this class to be taught in one day. We started at 9 a.m. and really we ended around 3 or 4. We actually went till 5, but mostly after that it was the kids messing around on the Raspberry Pis. It was a beginner level class. It wasn't complete. We didn't go over certain things. We definitely had to streamline. For instance, we never covered dictionaries. We actually nuked slices from the second day. There were I didn't cover title case or anything like that. And it was very open-ended. At the end of the day, we're like, hey guys, do what you want. What do you want to do? And actually what surprised me was even though the kids had internet connection and certainly knew how to get to their favorite sites, they all opened the books and started typing in the examples, which was just absolutely fantastic. This was actually worked well from everywhere from ages 8 to 18. We had older kids that did really well with this. We had little tiny 8-year-olds who were pecking away. It was absolutely adorable.
One thing I did want to point out, when I developed the slides, actually, there are 2 pieces of the curriculum. We had a set of slides, and we had Katie's Raspberry Rogue game that we walked through. The slides were actually built from an adult curriculum that I've taught to women. We pulled a few things out that I thought might be confusing for the kids, but otherwise it was basically an adult class, and the only difference really was the amount of time that it took for them to get through these concepts. So it was pretty comprehensible for the students, from the 8-year-old all the way up to the 17-year-old that we had the following day. Okay. So the reason we're doing this lightning talk is because a lot of you have asked us to post the slides so that you can take them home and teach them in your communities. There are just a couple things that I want to recommend if you're going to do that. One of the things that we found is that the kids weren't able to type as quickly as we were when we were doing examples and when Katie was doing her amazing live coding samples. A couple of the kids, they just couldn't type as quickly, and so they would realize that they weren't able to keep up and they would kind of give up and back off. So one of the things that I tried to do a little more on the second day was to give students time to type and run their own examples, give them a few minutes, make sure that everyone had gotten it, and then go back and type the examples ourselves, demonstrate them slowly, make sure that everyone got it before we moved on to the next topic. We gave students as much time as they needed and made sure to take plenty of breaks so that they had time to hack around on their own, in between subjects.
Our volunteers were absolutely awesome. We had about a 3-to-1 or 2-to-1 ratio, and we thought that was high, but it really wasn't. We asked the volunteers to stand at the back of the room and kind of watch for errors and kind of watch for kids struggling and getting discouraged and ask them to step in and reiterate what we were teaching quietly. If they noticed an error, they would grab us, pull us aside, say, hey, I noticed this. They would also, I'd say, hey, is everyone okay? I'd make a notion, and they're like, yeah, go on. Because kids are really hard to read from the front. They're really good at faking it. But here's some volunteers helping some of the students. And we want to give a huge thanks to all our volunteers. This class would not have been possible without them.
Take the whole 5 minutes almost. So here are the URLs. If you go to our GitHub repositories, I'm Mechanical Girl, she's Kay Cunny. You'll find the tutorial slides up there as well as the game code. And eventually we'll probably both blog about the experience so you get a little more full description. But there are blogs, therealkatie.net and mechanicalgirl.com.
Frenetic applause. Katie and Barbara, thank you so much.
Thanks, Katie. Thanks, Barbara.
Our next speaker will be Jack Minardi about sensors and actuator control with which little computer? Correct, Raspberry Pi. Jack, are you ready?
I am.
Okay, start.
Okay, thanks everyone for coming out. I have a Raspberry Pi. I wish you could see this. I'll be demoing it up in the lab at around 7:30 tonight, so if you want to come by and see it actually working. I have a Raspberry Pi connected to various different sensors. You can see up on the screen all the different sensors I have. I have a distance sensor down here, and I have a 3-axis accelerometer that's just measuring the gravity in 3 axes. I have a potentiometer, which is just a knob, and then I have a switch, which is just binary, so 1 or 0. And then over here, I also have some actuators I can control, like a servo. If I drag this slider, I could. If you're in the front row, you might be able to actually see it moving. And then in my UI, I can drag and drop connections in between these inputs and outputs. So on the left, the plots are the inputs, and on the right are the outputs. So if I want to take the potentiometer and connect it to the servo, I just drag a line like that, and now moving the potentiometer will control the servo. We were supposed to have a video camera up here showing this happening, but that didn't happen. So how this is working, I have a Wi-Fi chip on the Raspberry Pi, and in the Raspberry Pi I'm running 0MQ, so I just run a 0MQ server on the Pi, and then from the laptop I open up a socket connection to the Pi, and I ask it, hey, give me your sensor data, and then it'll respond giving the latest sensor values. And then I use these open source plotting libraries that my company produces to plot everything that's happening. And that's basically it. Thank you.
Thanks very much. Thanks very much, Jake.
You don't have to use
Jack.
the 5 minutes. Perfect. Thank you very much, Jack.
We should always remember lightning talks are a maximum of 5 minutes.
And max is a separate function in Python. You need to call a method. That's awesome. Listen to Raymond. Amy Smith is our next speaker. She will talk about Python and ArcGIS for transit data analysis. Transit data is when people stand in the traffic jam.
Yes and no.
Yes and no. To learn more, listen to Amy Smith. Are you ready?
Yes, thank you.
The stage is yours.
Thanks, everyone. So I work for Fair & Pierce, a transportation consulting firm, and a lot of what I do is geographic information systems. Most of the time, I'm handed a lot of GPS data, either from autos or buses. So today I'm going to tell you a little bit about how I used Python and ArcGIS to study transit data in San Francisco. To give you a little bit more of a background, the San Francisco Municipal Transportation Authority handed us a huge CSV with about a month's worth of data from one of their buses. And so in this CSV, we had GPS points that included information like the X and Y coordinates, time, and what route they were on. Our challenge was to take this data and split the routes into their individual trips which is if you think of a bus route going along a particular street, the trip changes when the bus turns around and heads the other direction. Now, the data didn't have this information included in it, so we had to run a spatial analysis that went point by point, figured out when the bus turned around, when it changed direction, and gave it a new trip ID based on that. And once we had all of the appropriate variables, we could calculate travel statistics based on however the engineer, their planner, wanted to break up their study area. So basically, we were taking all of this text file data and turning it into a useful map that gives us an idea of the average speed along the route, the standard deviation of travel time, and the standard deviation of travel time divided by the average travel time, which well, it's complicated, but it gives you an idea of what the reliability of your transit route is like. In a nutshell, we used ArcPy and the linear referencing tools in ArcGIS to take all of our GPS points and snap them to a roadway centerline. From there, we went point by point and figured out where the new trips were. And in order to get our study areas, we had to insert these points at the beginning and ending of where those study areas fell in our data set. We then used NumPy to calculate the average speed, travel time, and all those other fun statistics that the planners find useful. And because all of our planners and engineers are a little more comfortable looking at data in Excel, I used XLWT to export the data into an Excel file and color code all the cells based on values. And also there was an output that was geospatial so they could import it into ArcGIS. In order to share these tools with other people, one thing we do at Fair and Peers is we use a script template that's common across all of our scripts so that people can pick it up easily and read it and find out what's going on. And then finally, for those people who aren't really interested in digging into the code and just want to use the tool in a GIS environment, we create what's called a script tool, which is a friendly user interface that lets people access the Python scripts through ArcGIS Desktop. And that's it. Thank you very much.
Thank you very much, Amy.
Well done, Amy. Well done. Thank you very much. You know, it's really great having a German on stage today. Finally, there's somebody at PyCon that I and the Americans can agree has a funny accent.
There is one thing. I was really hurt by not by Steve, no. Has anybody of you seen Pitch Perfect? The new movie? It's quite nice, but there's one scene with the heroine. She knows that Darth Vader is the father of Luke.
What?
Spoiler alert!
And she explains it because father, Darth Vader, Vater on German is father. And then the guy she will, or will not, I don't spoil that movie, get at the end, tells her, so you know German, no wonder you don't like fun.
Okay, if Ed Kern happens... Oh, I'm sorry, hadn't you finished? This is not a lightning story. If Ed Kern happens to be in the audience, you didn't collect your T-shirt yet, and the ticket's here, so come and see me afterwards.
Okay, Quinn, are you ready? Quinn Weaver will talk to us about semantic versioning.
Thank you. Can you hear me all right? Yes. Great. So, I'm Quinn Weaver, and I'm terrified of public speaking. So I decided I better do some. So I wrote this talk, starting about an hour ago, in a presentation package called Emacs. this is a talk not about Python specifically, but about software version management in general, applicable to Python. Now, I'm going to state the big idea up front. The version number should represent an API contract with your user. Even if you're not a library, you don't have an API, you have behavior. Think of that as your API. You are stating something about how behavior changes across versions that's encoded in that number. That means someone can look at the number and know, hey, did things break? Did the API break? What happened? So, to say that in a little more detail, the problem is you want to know which version is the latest stable version of the package. And you want to know easily. And really easily. Like, just look at the version number. And this can be actually a real problem for distros, for instance, Linux distros, say, because they want to be conservative. They do not want to crash your servers. So they tend to want to use older versions. But they still want to include new features once they come out, once they're stable. I think probably everyone here has experienced having some favorite package, and you're like, why don't they add this to the distro, the latest version? I really need these features. So they can get it wrong. They can be too conservative. And by the way, sometimes if you're too conservative, you use an obsolete version. That can be just as insecure and buggy as a bleeding edge version. So you don't want to do that. Would it be nice if the version number told you something if it were a contract? Yeah. In Semver, it is. Now, by the way, this is not my idea. This is Tom Preston Werner's idea. Is he in the room? No. I am massively oversimplifying his idea. There's a whole spec for it. It's a web page. It's a couple screens long. Please read it. Don't take what I'm saying as the gospel. Don't make me into Brian and the Life of Brian. That would be bad. So let's dive into an example that's concrete. I wrote this library, let's say, called PyBread, and it's for controlling bread machines. I love making bread at home. I want to be able to program my bread machine to do stuff for me. Oop. It's got an API. Every Semver program has an API, as I mentioned. So let's say 6.4.2 is the current version. 6 major, 4 is minor, and 2 is the patch version. And, oh, I found I've got a problem. I'm burning bread in some circumstances. Let's patch it. I make a patch release, and so that's 6.4.3. The patch version number changes. Patch release means bug fix, nothing else but bug fix. The API must be otherwise unchanged. No even new features are allowed. And so it must be backwards compatible by definition. Great, that worked. Well, let's add a call that makes just the dough, but not the bread, because some bread makers can do that. That's a new feature that we're adding to the API. So we got to bump up the version number from 6.4.3 to 6.5.0. We're bumping up the minor. Thank you, the minor version number. So minor releases are for new features. Add something to the API. They're still backwards compatible because you can still call the old API, it won't break. And minor releases can include bug fixes as well, if you want. Just do whatever suits your dev branching style. Okay, great. So the dough feature is working. We're at 6.5.0. But now I realize I've made a mistake in my API. I've been assuming that bread always rises twice. And so you pass in the rise time to the API, and you got to pass in 2 rise times, rise time 1, rise time 2. If one of those, say the second one's undefined, error, exception. Well, I realized that, hey, you can actually have rise time 2 be none. So I've got to make an API change. This is major version change, so we've got to bump the major number. Again, major version changes are for changing the API. This will break backwards compatibility, because you don't have the same behavior anymore if some doesn't pass in rise time 2. And you must use a new major version number to indicate this. None of this sneaking API changes in. All right, so that's it. It's helpful. It conveys information. Thanks a lot.
Thank you so much, Quinn. Thank you so much. Semantic versioning on time, interrupted.
So, having told a joke about Germans, I suppose, being a Yorkshireman, I could tell a joke about Yorkshire people. The question is sometimes asked, what's the difference between a Yorkshireman and a coconut? And the answer is you can get a drink out of a coconut. So what's up next, Harold?
Next is Jason L. Kenny. Are you ready?
I am.
He'll talk about parts and SCONs, build systems in Python. The stage is yours.
Right, so we're all here for Python. As many of us probably do, we deal with other languages and we have to build them. We don't have the convenience of just saying, Python, do something, and it byte compiles for you automatically. For the job I actually do, we compile a lot of C++ code here. So we have a build system that we have that's open source. We base it on a system called SCONs that's open source. And it's been very productive for us to be able to support large projects and have a lot of shared components. So basically, a quick overview here is what is SCONs? It's a build system written in Python. Python turns out to be a great way to write build systems. It's intended to be a cross-platform make replacement. It's written by a guy named Steve Knight, who I believe works at Google at the moment, though we haven't heard from him for a while. You can get information about it at scons.org. What is parts? Well, parts is basically something I've been writing with the help of a few other people. It's an extension to the SCONs build system. It's written in Python, of course. It's meant to enhance SCONs via basically defining a plug-and-play component version model structure, which is very useful when you're doing, enterprise development and even open source development. You have versions that are useful. We have an improved toolchain configuration management system, easy to do cross builds. It has really fast startup times on rebuilds. At least that's what we're adding to SCONs, making it really fast to do that stuff. And we do a number of other things which are nice to have too. So why use it? If you're doing large build, cross-build type systems with like cross-geo teams, for example, one of the biggest problems you have is duplicating the environment. Commonly, it's a copy exact model you tend to do. It doesn't really usually work too well. This makes it very easy to do a duplicate exact environment, since the build system will actually set up the environment for the commands to run in, which makes it much simpler to support development for different environments on the same command line without having to reset it all up again. It scales better for large build systems. There's a lot to be said there, but we're quick here, so I'll just say it scales much better for large build systems. It makes it easier to reuse different components across different projects, which is the whole point of the plug-and-play idea. VTune is one of the projects that basically I work on or have been working on. It has over 700 to 1,000 components in it, given what's going on at a given point in time. And imagine trying to support a make system with 1,000 make files in it. I think you'd go insane pretty quick. This is something we've been able to support with one person being able to support this product as well as 3 other products going on at the same time. This is information where you can get it. But saying that type of stuff is boring. The question is that what can it do? Can you show it to me? So let's show you a quick example of what it might look like to give you an idea. It's based up mainly based on the idea of having a construct file which defines what you're going to do. Parts adds the idea of a part or a component. Part basically comes from SCONs being a construction methodology, and part seems to be a great way to make pieces, so that's how we came up with the name part. So here we have a simple hello world example type thing where we have a component called hello, and we say it's in the hello part thing, and we have another thing that's going to do the print code, let's say, and it's in this print message part. The part files themselves are generally pretty simple for the most part. This is print message. We're saying I want to compile this CPP file here as a shared library down here. We want to add some variables and all that type of stuff. We want to install it, so there's this idea of packaging that might go along with it. And then we have this header file that's part of the SDK, things we want to share with other components. Hello, basically, oops, of course I do that. So really quickly, I'll just bring that right back up here. So hello basically says, I have a part, I'm called hello. I depend on print message version 1.star. Basically, I'm making a program, and I want to install this thing called, that we're building hello. And that's basically what I have to do. What's nice about this is then, from a simple point of view, so I can say something like, I just have to say something like SCONs, I want to build everything, and, I might want to be able to say this is a 64-bit Windows machine. I may want to say I want to target something simple like I want to target just x86, for example. And all I have to do is go and it'll cross-build this thing, and it'll use, in my case, the Intel compiler, because that's what I have on by default. But if I want to, I can basically say I want a different tool chain. I want to say I want to use the Microsoft compiler, say version 9 or something like that. And it builds, and that's all you have to do. Voila. And it's super simple. Anyone can do it. Another nice thing about the cross-build environments, I'll just do a quick example over here, is that, maybe I want to cross-compile for the NDK on Android, voila. Oops, that's going to do a clean. It's not going to be very useful. Voila, here basically I have an Android x86 binary. You could use apt-get, wherever the right tool is supposed to use to move it over to the Android device and run it. But maybe you don't want to use the x86. You want to do nice good old ARM. I say ARM, voila. And there it goes. So that's what I got. Thank you very much.
Jason Elkenny,
Well done, Jason. Thanks very much.
Thank you so much. Our next talk has a title that I have to read very slowly. That's one of the reasons why I love being part of the Python community. Debugging Python on Linux with Visual Studio. If you need a reason why the Python community is great, just this talk and the title answers all. Steve Dower from Microsoft, are you ready?
I am, let's go.
We are looking forward. Woo! Give him a big hand.
Thank you. So, my name's Steve, I'm an engineer at Microsoft, I work on Python. One of the projects we're working on is Python Tools for Visual Studio. It's a free, open source extension for Visual Studio to give you all the editing functionality that Visual Studio has that I know you all love. I know half of you have VMs just for Visual Studio, and I know the other half have VMs just for testing IE. So, there is no reason why you can't all use this. And today I'm going to do I don't want to build this up too much, but this is a very risky demo. It relies entirely on having an active internet connection at a conference. So I'm taking a risk, but hopefully it's all going to work out. So what I have here is a short little Python app. It's a guess the number game. I'll just hit F5 and start running it. It's a simple question. Steve is my name. And straight away we've hit a breakpoint. That's in there. That's okay. We'll come back to this later. I'll hit F5 to continue for now. Well, Steve, I'm thinking of a number between 1 and 20. Take a guess. What number should we guess first? 4. Let's go with 10. I don't want to take too long. 15, 18, 17. There we go. Good job. You guessed my number in 5 guesses. Now that's great. We've hit another breakpoint, which is why we've come back here. And the game is over. So, let's make this a little more interesting. I have here an Ubuntu virtual machine that's running on Windows Azure. This is a live connection over the internet. It's up in the cloud. Please turn off your BitTorrent clients. I don't want this going down. And we can do exactly the same thing. It's the same program. What's your name? Steve. Tulu. 4 guesses. So I'm getting better. I can do even better again, because what I'm going to do this time is cheat. So I have the script here. We saw that I can already debug on Windows just by hitting F5, and we hit the breakpoints. It's a different story on Linux. It's a different story on Mac. This also works on Mac as well, but I can't do a VM of that. So what I'm going to do here is start typing. I'm going to import our debugger module, Python Tools for Visual Studio, PTVS-D is the debugger. And then inside that, I'm going to call this enable attach function. Here I can put in SSL certificates, restrict the address. I'm just going to put a little password. Let's use PyCon. And that's all the changes that I've had to make to my code. I can run over to PSCP and let's upload that. Good. And now, back onto the virtual machine, and we'll run it again. So now it's exactly the same script with those 2 little changes. Our debugger is live, it's running inside it. I can come back over to Visual Studio, bring up the attach to process, I'll put in the qualifier, which I prepared earlier. And we see, yes, a list. We see the process that's running on that virtual machine up in the cloud. Double click on that, and I've attached to it. Our debugger is running or attached to this virtual machine. So now I can come back here and continue the game. What's your name? Steve. And we've hit a breakpoint. The Visual Studio on Windows. We can see the call stack. We can jump up to where we were called from. Everything you could normally do inside Visual Studio. The thing we're interested in here is our local variables. We can see my name there. I enter that into name. If I step down a couple of lines, Oh, random.randint. That might be picking the number. So let's continue. Well, Steve, I'm thinking of a number between 1 and 20. Take a guess. 42. Good job, Steve. You guessed my number in 1 guesses. And here we can see the output is actually being sent back to Visual Studio. There's no need to be SSH'd into the machine at all. We can do it completely remotely. We don't need to be logged into the machine. This can be running in production. Our debugger, until you actually break into it, is very lightweight. And so when you need to attach to it, you can call this enable attach when something goes wrong. Print a message, turn on enable attach. You've sent an SMS to your engineer. He can fire up his, he can reboot into his Windows partition. Or start up Parallels and log in.
Steve Dauer, debugging Python on Linux with Visual Studio. Wonderful.
So nobody can say that Microsoft aren't taking Python seriously on the cloud. Thanks, Steve.
Great. They can. I would like to ask for Dusty Bushuki. He'd already checked in, but we don't find him anymore.
If you're around, Dusty, okay. Just sit at the front there where we know where you are, please, so we can schedule you in.
We also need Charles Law. You're also
Charles
here,
Law.
great.
Okay, just stick near Brian there.
So our next speaker will be Roberto de Almeida. Did I pronounce it nearly correct with German accent? Yes. That's my trademark. My British friends from the PyCon UK invited me for this trademark German accent because there was one really wonderful guy with a great idea, and he gave a lightning talk, and he asked me, can I do a second lightning talk right now? And there's one thing, the show must go on, and it's impossible to have 2 lightning talks in a row because it would violate the 5-minute rules. So I just told him no. And I planned to explain it later to him, and sorry, show must go on, da-da-da-da-da. Then the others told me, no, it was perfectly fine. You used your German accent, and he understood. It's a stop. Okay, Roberto de Almeida, JSON Store. You ready?
Yes.
Stage is yours.
Okay. Good afternoon. So I'm Rob. I'm going to talk about JSON Store. It's a model that I wrote. This is my Twitter handle. And well, JSON Store, I wrote it because I needed a local storage for dictionaries and like JSON objects, Python representation of JSON objects. So if you look at the code, it's very simple. You have an entry manager, and it's based on SQLite. So you create a dictionary. When you add a dictionary, it will have an ID automatically assigned and an updated timestamp. You can also add nested structures. So here we have a dictionary with a dictionary inside with a list. So you can combine lists, numbers, strings, and dictionaries. So basically, I reinvented Pickle. So this is a little bit more. So you can search for documents. So the way it works, you pass a subset of the document you want to search. So here I'm searching for any documents that have bar equal to 1, or I can do nested searches. And like Baz is a dictionary with foo equal 1. And this is not very useful. So we have operators also. So here I'm doing a search where I have a key bar that exists. So we return all documents that have bar. And I can use this in like nested patterns. So dictionary where Baz has foo, which is less than a given number. So I have all the basic operators for this. And this is from 2006. So NoSQL before it was cool. And after I had this, I decided to build a REST server on top of it. So it's a full REST server, supports get, head, post. You can patch your documents, you can delete them, has meaningful status codes as responses. You can use e-tags and if match header, so you can do conditional updates if you want to do a counter. Output is JSON, has support for padded JSON if you want to embed into JavaScript from a different host. Has support for Ryzen, which is a compact notation of JSON for URLs. Has webhooks. You run it like this. So just type JSON Store. It's on Cheese Shop, and it will run. So here I'm using curl to do a search. Just do a GET request. You get all the documents paginated. You can add documents using the REST interface. So if you do a post, you create a document. So on the top, we're creating a document. Then we can search our store from the Python side. We'll see the new document. And once I have the HTTP REST interface, I re-implemented the API on top of REST. So I have the same interface that I use for SQLite, I have on top of REST. So you can connect to a remote JSON store and search, for example. And once we have SQL, and then we have the JSON Store API, we have the REST server, and then we have the REST client on top of it implementing the same APIs, we can start doing like fun things. So this, I made this DSL, where you connect to a store, and then we can use right shift to add documents to the store. So you create a dictionary, do a right shift to the store, and then it's added to a store using a post request to the HTTP REST server. And you can do searches. So this is like you use a Unix pipe, you pass dictionary. So here we're getting our data, our storage. We look for all documents that have message that start with hello. So we get our hello world message. You can remove items. So if you do a left shift from an entry, you're going to remove it. So you can do things like this. So for every entry in our store, we filter by message exists, and then we remove that entry from the store. And remember, this is running over HTTP. So finally, Posteros is closing down. I had all my blog posts on Posteros, but I had the insight of putting a webhook that added all my posts to a JSON store that I have running on db.thealmeida.net. And with this, I can simply do a backup from my Posteros posts to a local file. So this is the address. It's on Bitbucket, and it's also on PyPy, Cheese Shop. So if you want to hack, if you want to contribute, this is the address. Thank you.
Robert Almeida, JSON Store. Give him a big hand.
Well done.
Great. Mike?
Okay, so here's a question for you. What's the difference between an introvert geek and an extrovert geek?
The extrovert looks at his shoe or your shoes.
Yep, that's right. The introvert geek looks at his shoes. The extrovert geek looks at yours. Okay, so who's up next, Harold?
Next is Mike Fotinakis about Titan files for App Engine. Are you ready for the job? Mm-hmm. Okay, Mike Fotinakis, give him a big hand.
Go, Mike.
Woo.
Hi, everybody. Hi, I'm Mike Fotinakis. I'm from Web Studio Tools Engineering at Google. So I help build internal tools at Google, including our internal CMS that helps build all of Google's websites and marketing pages. So I use Python and App Engine all day, and this is a talk for the App Engine users out there and the future App Engine users out there. So first, I was going to talk about Titan files, but first let me show you the shiny thing, Titan tasks. This is a little thing that's built on top of Titan files. And this uses the task queue API. And traditionally, it's been kind of hard to get data out of the task queue API, like statistics on how many tasks are in the queue, or be able to group tasks and tell how many have failed or finished. You can sort of get how many have finished in the last minute, but it's sort of not very granular. So here's a demo of a library that you can use that we built that's pretty generic. So let me tell you what's going to happen before I click it. This will go ahead and just defer a bunch of tasks. I'll make it defer 100 tasks, which I'll create a widget or do whatever. You can imagine this as like every row that you have in any application you want with all of your data, and you want to provide users a way to click a button and do some processing across all of them and provide real-time feedback across how or when those things get processed and if they failed and any errors. So this will do that in the background. This uses both the task API and the channel API to provide real-time feedback. So there's only a single HTTP connection open at this time, and each of these get queued, and then you can see when the task queue in App Engine decides to schedule them not in order, and then custom error messages, and you get sort of real-time feedback on any of the tasks that you have processing. So that can be really useful for you out there who need more granular statistics over your tasks. This is built on top of a system that we have. These are all libraries that we've open sourced, and this is built on top of a system called Titan Files, which is another way of storing data in App Engine. It uses the data store and the blob store underneath. So it's a file system abstraction for App Engine, and can be really useful for apps that want to manage arbitrary data instead of making DB models or NDB models. So if you're migrating your app to App Engine and you happen to rely on files in your local app or some other system, and you want to port it to App Engine, this can help you do that. And it's also really helpful for managing static files in your app and then not having to manage them with a code pusher doing another deploy. You can manage them directly in the app. So it's a really simple API. You just from Titan import files, and you can create these file objects, and then you can do what you normally would think of doing with files. You can write them, you can copy them, don't let it throw you that it's not in PEP8, and move to, serialize, you can delete them, and then there's some interesting properties on them that are useful, like there's a pre-computed MD5 hash MIME types that are directly servable as the content type. It uses an NDB expando model underneath, so you can actually assign arbitrary metadata to the file and then query on that data because it's all flat underneath. We also provide command line tools for uploading and downloading data, so you can run this command line tool, upload a bunch of files directly to your App Engine app, and then access them with the file object immediately without any extra work or any setup. And you can also download, so it's really good for data portability. If you want to pull all the data out of your app, you don't have to really go through the bulk upload or YAML and writing the files and getting them CSVs and transferring them into other files. You can just sort of download all of them, and they're immediately in the same format that they were stored at because it's all just files. We also support that metadata that I was talking about because it's normally stored in the data store and blob store for big files. You can do standard queries across it, so you can do a files list in some directory recursively with some filters, like if I've tagged a bunch of files with the color blue, then I can immediately get all of those files, the names of those files out of the data store and interact with them as Titan file objects. So we have an internal app that has 8 million Titan files in it, and I can immediately recursively across all of them get any files that I want tagged with certain information. Like you can use this for permissions or any arbitrary system that you want, and it's immediate because it's a NoSQL database and they're all just flat in the background, even though it presents to you a file system-like API. And we also have some other things on top of that library that we built, like Titan versions. So every good file system deserves a good lightweight version control system on top of it. So we also built a version control system on top of it that lets you do atomic changes across lots of different files. So if you need to guarantee that a directory, a bunch of files all change at exactly the same time, like with a web server when you don't want your JavaScript or your images or anything to be out of date, or to go up and serially, you want it to all happen instantly, then you can use the Titan versions to do that. We also did Titan micro versions, which lets you automatically version every change that ever happens to any file in the entire file system. So we use that to present our users with history of anything they've edited in our UI. And then also Titan stats, which is stores counters. You can access all of this at code.google.com/p/Titan files. And there's my contact information if you want to get in contact with me about it. So,
Mike Fordinakis, Titan Files for App Engine. Thank you so much.
Well done, Mike. Thank you.
We've got one official more lightning talk from Dusty Phillips about using Git as a Mercurial client, as always Python building bridges. I just want to ask Chen and Maximilian just to stand up and you all to give them a big hand. It was so great to have people in the front dealing with a bunch of adapter blocks. If you look at it, it's crazy.
It's not a pretty sight up there.
It's not a pretty sight, but I'm usually bent to people coming in the front and asking, has anybody a chops plug? And now all the plugs are here. It's wonderful. Our next speaker does not need an adapter for his video. Dusty Phillips about using Git as a Mercurial client.
Go, Dusty.
I've never actually been in front of a microphone before, and I have to give a little compliment to Quinn for doing the public speaking thing, and I wanted to one-up him a bit by doing it without slides. Thanks. The actual reason for that, I work for a company called YouGov, and it's a great place to work, but I have two complaints. One is that they gave me a laptop that is heavier than I am, and so that's the reason I don't have slides. The other is that they use Mercurial, and I'm not sure if I'm going to survive the night for saying that. But I really don't like Mercurial. I found that out after I joined YouGov. And I complained a bit, just a little bit, and I got accused of whining and bike shedding. So I complained some more. And then I took Christmas holidays and I decided that I didn't want to whine anymore. And I wrote an app called Gitify HG. And on my slides that aren't here, you can see the URL. But since you can't, you'll have to search Google for it and you'll find it and me. It uses the Git remote protocol, like several previous attempts, but unlike several previous attempts, it works for me in production. I've been using it for about 3 months. Some of my coworkers who are on my side, and they also complain they don't get accused of whining, they use it regularly as well. It's as easy to use as just git clone, gitify hg, : followed by a Mercurial URL. And then from there you can just use it like Git. There's a couple of caveats like don't try and push an octopus merge. And also it doesn't interact too well with anonymous heads, so don't let your coworkers push anonymous heads to Mercurial. Don't do that anyway. Like I said, it's an unprepared talk.
Now, Steve told me he's got a 16-second lightning talk, which is perfect because it will fit into the remaining 40 seconds, and we have 20 seconds to applaud him. Steve.
This is a talk about how to give a short lightning talk. Thank you very much.
So that's it for today's lightning talks. We need a big round of applause for all the speakers.
All speakers, thank you.
And also give yourself a big hand.